So hello everyone, today in this video we are going with angular displacement. So first of all we will go with the if I can make here the circle for the angular displacement. So here you can see this is the midpoint of the circle and it is making the radius here. Okay, radius. Fine. So now here if I can write the definition like here, angle subtended at the center of the circle. Angle subtended at the center of the circle. Angle subtended at the center of the circle when body moves from point P1 to P2 in the circumference of a circle. In a circumference of a circle. For example, here you can see if here I have P1 point and it will move here till here it is here we have another point which is P2. Okay, so here you can see here we have again this line, so angle which is subtended. How now you can see here the angle is made. Okay, so this is what when you will go from point P1 to point P2, the angle is subtended at the circumference of a circle, so that is known as angular displacement. Angular displacement. Okay, now another thing, the we can say path which is followed from P1 to P2, that path is known as path is called as arc length. Arc length, and this arc length is basically denoted by S. So now here if we can drive the formula, so it will be S is directly proportional to theta, means whenever the path like the we can say displacement from point P or to point 2 will be greater. For example, here I have another point 2. Okay, so this means now this path is greater. So when this path is greater, so this angle theta will be also greater. So this means arc length and is directly proportional to theta. Now here you can see, to remove this proportionality sign we will put S is equal to r theta. Now what does here r means? R is here basically the radius, and here radius is what? Here radius is constant, because as you can see in this diagram, here we have this radius, and whenever this path is moving and angle is subtending, the radius is constant, radius is not moving. Okay, so radius is here constant. Fine. So if I can go with the formula of theta, so theta means angular displacement is equal to S upon r, arc length upon we can say radius of a circle. Fine. After that, here we have for finding the unit or SI unit. So for the SI unit, we will do like here you can see if we have this arc length. So arc length is one type of displacement. So the angle is of the arc length, or you can say unit, is meter. Okay, and again radius, the radius unit is meter. So here meter will be cancelled. So here it has no unit. But here we denote one unit because it is noted it is radian. It is denoted by Earth's. Here we don't have any unit, right? Here we have denoted this is radian. Okay, as now this is basically the ratio, and this is basically the ratio between two lengths. Here this is also the length, this is also the length. So this is what ratio between the length, and when you are seeing the ratio, so remember the ratio don't have the unit. Okay, but here we give the unit which is radian. Now here you can see here we have what, if arc length is equal to radius of the circle, अगर हमारे पास क्या, if S is equal to R means arc length किसके बराबर होनी चाहिए, रेडियस के बराबर हो जाए, so the angular displacement क्या होगा, then theta will be basically थीटा विल बी 1 रेडियन। थीटा कितने के बराबर हो जाएगा? 1 रेडियन के। when when we have arc length is basically equal to radius, so then theta is equal to 1 radian. Okay, and if I talk about other units of this angular displacement, so other units includes, so these other units basically include degree and revolution. Okay, so yeah, the ratio between the radian and degree. Now if we, oh sorry, not ratio, if we are going to find out the relationship between the radian and degree. Okay, okay, for finding the relationship between radian and degree, we have what? First we know that for complete one revolution, for complete वन रेवोल्यूशन, एक रेवोल्यूशन कंप्लीट करना मीन्स एक पूरा चक्कर कंप्लीट करना. फॉर एग्जांपल हियर इफ आई कैन ड्रॉ सर्कल, सो इफ आई हैव हियर वन पॉइंट और यहाँ से मैं जाऊँ दोबारा मैं इसी पॉइंट पर आऊँ, दिस इज व्हाट वन रेवोल्यूशन. ओके, एंड यू नो फॉर कंप्लीटिंग द वन रेवोल्यूशन इट इज इक्वल टू s is equal to 2 pi r. Okay, which is what? Circumference of a circle. Circumference of a circle 2 pi r, and here we have formula which is s is equal to r theta. Okay, now s is given, which is what? 2 pi r, which is circumference of a circle, is equal to r, and you know it that in this, in one revolution the theta will be what? Theta will be equal to 360. Okay, क्योंकि यहाँ theta बन रहा था वो आधा 180, then here we have 270, then we have what? 360 total. Okay, 360 is the theta in the circular or angular, right? So here you can see radian, this is cancel. Now 2 radian is equal to 360. Okay, 2 radian is equal to 360, or you can see when you're gonna solve this, it will be 6.28 radian is equal to 360. So remember this, 2 radian is equal to 360. Fine. So for 1 radian, if we are going with the finding for the 1 radian, so yeah, for 1 radian, so here is like 1 radian is equal to basically 360 divide by 2 pi. 360 को whenever you will divide by 2 pi, you will get 1 radian. ठीक है, so it will be what? 360 divide by what? 6.25 to 8, sorry, not 5, because here pi is 3.142. Okay, so 1 radian will be equal to what? Whenever you will divide these both, it will be equal to 57.3. So remember this value, mostly it is asked 1 radian is equal to 57.3, and 2 radian is equal to 360. Okay, so if we have to find, like for example, I have 1 degree, right? So now for this degree we will having 2 pi divided by 360. Now it is basically the, we can say, up and down opposite, like here in for finding the 1 radian we were having 360 divided by 2 pi, but for finding the degree we have 2 pi divided by 360. So it will be what? It will be equal to 1. Okay, so this means we have what? This is 1 degree, right? So 1 degree is equal to, when we're gonna solve this, it will be equal to 0.014174, sorry, 174 radian. So this means 1 degree is equal to 0.0174 radian, and 1 radian is equal to 57.3 degree. Okay, I hope till that it is clear to you guys. Now let's move to find out the direction of this, we can say, angular displacement. I'm writing simple theta angular displacement. Okay. For finding the direction of this angular displacement, just remember one, we will find this by the right hand rule. Right hand rule. Now here to note out this, like how we're gonna find this by the right hand rule. This is like we have this one circle, like this is one circle, and here be a center, and if this direction is like this, means this is and for the anti-clockwise, so if it will move like this, so it will be what? It will be positive. And okay, and for the, you can say for the clockwise, so because when you're gonna move your hand clockwise, so direction will be what? Direction will be inward. And inward direction is always negative, and when you will move outside, so it will be positive and outward. Okay, you can do by putting your palm in the direction like on the anti-clockwise and clockwise, and you will find the thumb will be giving you the direction. So I hope that it is clear to you guys. Bye bye.